about Spintronics for future tech, which I thought was interesting, just from this whole discussion around, the future of computing. Where's it going to go? How's it going to manifest? What are some of the challenges underpinning it? We've spoken before about quantum computing needing, the right temperature to function, which is extremely low, of course. But I thought this was interesting, the idea of, if I'm getting this right, and maybe you can correct me if I'm wrong here, but the idea of angular momentum of an electron to store and read information. So the idea that its spin is also a place that can be exploited, I guess, to further enhance the ability of a potential future computer, which sounds like amazing to me. Like I have to give credit to these people that are studying these things, that it actually occurs to them that, oh, maybe we could have a look at that.
Yeah, it's unbelievable. So yeah, this is a concept in theoretical physics that now they've demonstrated. So they've actually shown that you can use this to create the energy, and you can use it for memory storage. So it would reduce the the energy required for all the storage that we need, and probably opens up a whole new range of solid state devices, from what I understand. So it's fascinating. It's beyond me to try to explain it, but it's so interesting, and I think one of the things we're seeing and have seen and will continue to see over the next decade, as we push towards moving away from fossil fuels, I think what we'll see increasingly is new techniques and new ways to save on energy generally, as much as generating new sources of energy. So this is something that helps us save energy and increases capacity. And I would imagine that the response times through this would make it an even more efficient means of managing and storing data. So it's unbelievable, brilliant.
Absolutely, and I think that that's the key that you mentioned, the focus towards energy efficiency and getting that down, because historically computing has kind of sucked up a lot of power. And anecdotally, I still have fun at my laptops, my work laptop anyway, that seems to be sounding like an air conditioner when even when I open Outlook
with the Intel processor generating temperatures around the core of the sun.
Yeah, that's right. Or latest iPhones or whatnot that are coming out. But it's interesting, and yeah, okay. Apple's taken some strides with their A and M series chips and has kind of demonstrated that you can do that. But this is one step further, because obviously, not to discount what Apple's done with the ARM chips, which are now going to progressively, go across the rest of the industry, and you already see them in Android phones and whatnot with the Snapdragon chips and whatnot. They're still based on a architecture that was developed in the 20th century, and for whatever reason, they're now starting to exploit it now. But this is like another level, well beyond that.
Yeah, that's exactly right, and what it unlocks now, is increased performance, and with the AI or the neural networks that you're finding increasingly on chips, that working to reduce power consumption, and then having this to reduce the power consumption on energy on storage, means that even without quantum computers, we're going to a whole new generation of desktop, laptop, personal computing.
And I guess one last thing that sort of came to mind, which might seem a little bit out of left field, but if you think of the human brain and how powerful it is, like as a computing unit, for lack of a better term, yet what it's able to do comparatively with on such less power, like it's a highly power efficient way. There's certainly an element in the universe that can allow for this to happen. And when you combine that with how scientists go out and try and discover these things, to me that's the amazing linkage that happens. That we've got examples of these things, and now we're trying to figure out almost how to reverse engineer them in a way to try and come up with our own sort of devices to take advantage of these things.
Exactly, and no matter how complicated the human memory is, as you say, it doesn't take a whole lot of power to store it. Not for some of us, anyway. And you know, if it's possible inside the human brain, then it must be possible to do something similar on a chip, or on a device. So yeah, perhaps we're starting to approach those sorts of levels of sophistication.